have the left sum and right sum?
Okay, why do we need the trapezoidal rule if we have the left sum and right sum? That's the question that Travis
Yes.
asked. Right. So it's really about what's more precise. So trapezoidal has better approximation than the left sum and right sum. Now, for practical purposes, as I said, Simpsons Rule is the most powerful, and it's just right. It's not too complicated. It's just a little complicated, but then it gives you such a good result that you want to use that. So in many cases, the left sum and right sum gives you poor results, so you don't want to use it. And unless, if the function is really rough, that you can't really trust the value, then in that case, you might just end up using the trapezoid. But see, we're teaching trapezoidal rule so that you can get acquainted with the Simpsons rule. Okay, so now let me try to explain to you what Simpsons rule and midpoint rules are. So first, the midpoint rule, which is kind of obvious. So what you do is, we need the midpoints of these intervals. So basically, these are the endpoints of the n intervals. See, when you're given a number n for this question, you're trying to divide this into n equal parts, right? So you get subintervals, and you end up with the endpoints of the subintervals. Midpoint rule tries to use the midpoints of each subintervals, and basically you need to find the midpoint of these two, and you end up with n subintervals. Okay. Now, how do you calculate midpoints of two numbers?
Add and divide by 2.
Yeah, you add them. You take the average. Average value is the midpoint, right? So what you're going to do is you're going to define x1 star as the midpoint of the first interval, which is x0 plus x1 over 2. x2 star as the midpoint of the second interval, which is x1 and x2. And you can do this until you get xn star. It's the midpoint of the last interval. Can anyone tell me what I should write here? X n minus 1 plus xn divided by 2. That's the midpoint of the last one. And then you build the rectangles whose height will be y, the y value over these points. So we'll be using f at x1 star as the height of the first rectangle, f x2 star as the height of the second rectangle, and then we're going to multiply delta x, the base length, to all of them. So when you add up everything, that's going to be what we call the midpoint value. It's quite annoying, to be honest, to actually calculate this. It's easy to say. Midpoint. What's a midpoint? You just take the average of the two endpoints and you calculate. But the actual amount of calculation you have to do in order to get a midpoint approximation is a lot, actually, because calculating these are quite annoying. Yeah, so I don't think it really justifies using the midpoint compared to trapezoid, although this has half the error as the trapezoid. I don't think it's very well justified. All right. Now, Simpsons Rule, so let me explain what Simpsons Rule is. And actually, I can't fully explain the Simpsons Rule. I'll have to defer the actual explanation to a later time. What it does is, if you have a bunch of curves, what Simpsons Rule does is, if you have like this, let's say you have this graph and you decide to approximate this using 3 subintervals. What it does is it builds parabolas. I kind of exaggerated the parabolas a bit, but it tries to come up with the parabola that's closest to the graph, and then it does some calculations. Okay, actually, it's even more complicated because this is not the case for n equals to 3. This is actually the case for n equals to 3, n equals to 6, because the way you build a parabola, you need 2 points to draw a line, right? To build a parabola, you need how many points? You need 3 points. If you have 3 points, that determines a parabola. So what it does is it uses points in the end point and the middle point to build a parabola, and then uses that as the approximation. Okay, so that's what Simpsons Rule is. And the actual derivation of the formula is quite complicated, but what I'm trying to say is like the following. The Simpsons Rule is very similar to the trapezoid in the sense that it has the same structure. So it's delta x, rather than over 2, you use over 3. And then, rather than having just 1, 2, 2, 2, 2, and then 1, rather than that, it uses 1, 4, 2, 4, 2, 4, 2, 4, it alternates, and then comes back to 1. Okay, so the first one is 1, and it alternates, after that, it alternates between the two values, 4 and 2 and 4 and 2. Okay, so f of x1 plus 2 f of x2 plus 4 f of x3 plus 2 f of x4. You know what I mean, right? It's 4, 2, 4, 2. Until all the way at the end, you end up with the 4 f of xn minus 1 plus f of xn. Now, how can I guarantee that it's going to end with 4? If I start with 4, how can I guarantee that it should end with 4? Well, the only way you can guarantee it is when you assume that n is even. So this is actually a condition. So this is a condition that must be satisfied before applying the Simpsons Rule. If n is not an even number, then when you do 4 to 4 to 4, you're going to end at 2, and then the next one will be f, and that actually has a very high error. It's actually not a good approximation. So Simpsons Rule only works when it's an even number. Okay. Now let's try to view these questions a little bit in a slightly different way. So suppose I need some room to put these. I'll delete here. So I want to elaborate these formulas a little bit, where what this 3 is about, what 4 is about, what 2 is about. So So it's like this. If you have some function, and let's just say n is 4 for a minute. Okay, so n equals to 4. Just to make things simpler. So we have just 4 subintervals. Now, the formula for this one is delta x would be b minus a over 4, because n is 4. So that t would be b minus a times 4 over 4 divided by 2, f of x0 plus 2f of x0, x1, 2f of x2 plus 2f of x3 plus f of x4. N is 4, that's where it's going to end, right? Now, this is 1/8. 4 times 2 is 8. And how many items are you adding here? There's 1, 2, 3, 4, 5, 6, 7, 8. So if you add 8 objects and divide by 8, what are you really doing? You're calculating the average, okay? In other words, you can think of this thing as calculating the weighted average of the function values, okay? So where the ones in between are weighted more than the endpoints, okay? And then what you're doing is, so what happens is that if you have a function, you can think about some kind of an average, right? That's like the average value of the function. And if you take the average value and multiply the base area, base length, you're going to get the area of this rectangle, which is pretty close to the area under the curve, right? So that's what's happening in these formulas. Okay? So see, this really has b minus a over n, and you're adding n objects. So if you divide n objects by n, then you get an average of these values, and you're multiplying by the over interval size. So that's what's happening here. Does that make sense? Now, then what does this mean? Well, let's try to write the Simpsons rule for this one. S is equal to b minus a over 3. And you have f of x0. Oh, sorry. B minus a over 4 times 3. Okay? And then you have f of x0, 4, 2, 4, and then the last one is just 1. As I said, it just repeats 4, 2, 4, 2, right? Okay. All right, so again, the same story. 4 times 3 is 12. You have 1 plus 4 plus 2 plus 4 plus 1. How many objects? 12 objects. Okay. So this is like the weighted average of these values, where these two are counted more than the other ones. And for some reasoning that's really not clear at this point, I'll have to have a separate explanation why that kind of weight is so effective. But if you accept that, then you can really think of all these formulas, whether you have a trapezoidal, left sum, right sum, Simpsons. These are all basically taking some form of weight, some form of weighted average times the base length, and you end up getting a rectangular area, and you're using that as the approximation. Okay. Now, what this amounts to is saying that if this wasn't 3, if this was something else, then it would totally be off. Right? There's a reason why it has to be 3. That's because when you have n times 3, that actually gives you the total number of the numbers that you have. So that's the hidden part that they don't tell you in the textbooks.